Welcome to this update. I want to focus on this new variant that's spreading rapidly throughout the United Kingdom and does seem to have spread to other parts of the world already. Now, we've got some facts on this now from Public Health England, who have done quite a big survey on this. And what they've done is compared people with the new variant to people with the old wild type variant. And they've come up with some fairly hard facts, so I think we want to get to the evidence wherever we can. Now, I'm going to give you the bottom line now in case you're short of time. First question, is there increased risk of reinfection? So if someone's been infected, are they likely to be reinfected? The answer is no from this data. They are not more likely to be reinfected. They're not at greater risk of reinfection. Second, is there implications for vaccine efficacy? There's no evidence that in this data that it will affect vaccine efficacy, so I expect vaccine efficacy to work, to be the same. In other words, the vaccines will work just as well as with the old variant. Does this new variant cause more severe illness? This data says no, it doesn't. Does this variant increase the risk of being hospitalised? This data says no, it doesn't. Does this data indicate that there's more deaths from the new variant? No, there isn't. From this information, there's no more deaths. Is there an increased rate of transmission? Yes, there is. How much is the transmission increased? Looks like 50 to 55% from this data. And we've got two data sets for this now, 50 to 55%. Not as bad as we'd originally thought, but bad enough. Bad enough to mean this will become the predominant variant in the UK. And indeed, this means that this will be the pandemic in the UK from now on. In most areas now it's spreading. So is this 50 to 55% consistent with previous evidence? Yes, it is. Will this be the dominant strain in the UK? Yes, it will. Will it be the dominant strain in the world? I sincerely hope not. I sincerely hope the spread can be restricted to the United Kingdom. So that's the bottom line on that. I'm going to give you the evidence for where this comes from now. But before that, of course, it is the 29th of December. Now, I did say that the Oxford vaccine would be approved yesterday or today. It hasn't. My apologies, I got it wrong. It'll be tomorrow. Almost certainly tomorrow. Or it'll be this week. We had thought it'd be yesterday or today. It's not. So, but it's going to be soon, and it's going to be positive. Of that, I have no serious doubts. And I'm really hoping it's going to be tomorrow, but it will be this week. Right, so new variant. Let's get down to the evidence for this now, if you want to stick around for this. It is interesting, and the implications, of course, are for everywhere. This applies to the whole world, because in South Africa, of course, there's another very similar mutation has arisen in South Africa. Again, we've got increased rates of transmission in South Africa. Possibility of spread to other parts of Africa. So hard to tell because of the limited testing. And we still don't know about the situation in the United States come to that because of limited testing. I haven't read anything about the new variant being discovered in the United States, so hopefully it's not. But that is partly due to limited testing, limited genomic testing. Anyway, let's get down to the facts here. So this is called a VOC, a variant of concern. So this is the Public Health England site. Check it out for yourself. So VOC, variant of concern, 2020, the year, 12, the month, 01, it's the first one that's been discovered. I think it's as simple as that for the nomenclature. Anyway, published by Public Health England, so that's good. So it's 2020 for the year 12, and it's the first one discovered. I think that's the way it works. Right. Now, there's a 2-week delay on full genomic sequencing, so there's always a delay in this. But we know that it's the N501Y. That is the main mutation on the spike protein that makes this more transmissible. But it just so happens that associated with this mutation, in about 99.7% of cases, there's also an absence of amino acids 69 and 70. So deletion, so that's the Greek letter delta. So there's a deletion of amino acids 69 and 70 as well on the spike protein. Now, it just so happens that the PCR test that we use, that region 69 to 70 is one of the ones it targets. So it's targeting 3 regions to identify if those regions are there, and that just happens to be one of them. So we've been able to, or Public Health England have been able to map this much more accurately because they can get data from the normal PCR tests. So the 69-70 region comes up negative, the other 2 regions come up positive. That means that's the new variant. If the 69-70 region comes up positive and the other 2 areas it checks for both come up positive, then it's the old wild type variant. So we don't have to do this full, expensive, laborious 2-week delayed genomic testing because it just by sheer probability, the PCR test that we're using for the antigen picks this up. So I suppose in a sense you could say that's fortunate, really. I suppose you could say it's fortunate. So it shows up on the PCR test. The S gene target, so it's the S gene target failure. So that means SGTF. So it means it doesn't recognise that bit on the spike protein. That's how we tell. Now this is a cohort study that they've done. In other words, what they've done is they've taken data from lots and lots of testing, which Public Health England does, of course. It does a heck of a lot of testing, and basically they've taken that data and they've grouped together the people from the people that tested positive for the old wild type, and they're able to compare that with the people that tested positive for the new variant type, the 2020-12 new N501, the deletion 6970, whatever you want to call it. So they're comparing the new variant with the old variant. And because they can do this, basically they've got 2 groups, so they can do these clever comparison studies. So it's quite a neat piece of research. Okay, it's retrospective, but it's still good. It still gives 2 big cohorts because they have large testing numbers. So is there a greater risk of reinfection with the new variant compared to the wild type virus? So data collected from September to December. Now, reinfection is defined by a 90-day gap. So to diagnose a reinfection, so in other words, a reinfection is someone who's had SARS coronavirus 2. The body's cleared it. There's then been a 90-day gap and they've had it again. And both times it's been officially diagnosed. That's what we mean by reinfection. And we'll see that is very uncommon, fortunately. And the people that do get reinfected, from all the data we have so far, aren't getting sick. They're getting minimally symptomatic, or in fact, in nearly all cases, asymptomatic infection. They don't even know they've got it. There was 1 death in the Netherlands, but I think it was a 94-year-old lady who had a lot of comorbidities. So basically, the reinfections aren't a problem because people aren't getting sick. But it's still significant from this because we want to know if this one's causing any more reinfections. And of course, we know the answer is not, but let's look at it. So the new variant case group, there was 2 reinfections on that. So the reinfection rate for the new variant was 1.13%. Sorry, 1.13 out of 1,000 cases. So 1.13 per 1,000. So how many people get reinfected of those that are tested? The answer is about 1 in 1,000. So that's interesting. 1 in 1,000 or slightly less than 1 in 1,000 from some data we're going to look at in a minute. Anyway, so to stick to the point, the new variant, 1.13 reinfections per 1,000 diagnosed cases. The wild type, that's the old type, there were 3 reinfections, 1.7 per 1,000 cases. So we can see there was more reinfections with the old type virus. There was less reinfections with the new variant virus. Now this would indicate that there's less reinfections with the new variant virus, but the point is, statistically speaking, these numbers here are not statistically significantly different. So as the data set enlarges, these numbers could change a bit, but we would believe that there would be no significant difference between them. In other words, it's not a factor. The difference between those 2 numbers is not significant. So if it's not significant, it means those 2 numbers, statistically speaking, are the same. So that's good. We see there's no increase in the likelihood of reinfections. good piece. Good. Well, of course, it would be nicer if there were statistically less reinfections with a new variant, but there's not. It's just the same. So that's the same. Rate of detected reinfections. Now, looking at detected reinfections, reinfections with a wild type. That's the old type. There was 0.6 in this data set per 1,000 in this data set, and in this data set the equivalent comparison was 0.61 per 1,000 with the new variant. And of course there's no statistically significant difference between those numbers. They are basically the same. So again, this other way of looking at the data gives us the same results. Reinfections are not more common, so that's good. It would be nice if they were less common, but they're not more common anyway, so that's what we're worried about. Does this non-difference have implications for vaccine efficacy? So there's no difference. So basically what it's saying is the immune response generated to the old type virus gives immunity to the new type virus. The people are very, very, very unlikely. Only 0.61 per 1,000 get reinfected. So that has great implications for vaccine efficacy because it means the immunity to the old type virus covers for the new type virus. Therefore, the vaccine, which was designed for the old type virus, will cover for the new type virus as well. But I was going to say that there's it's what you call a polyclonal response. There's lots of different antibodies and lots of different aspects to the immune system that will still recognise this. So vaccine efficacy will remain good. That's not in this data. I've extrapolated that from this data, but that's done so on the grounds of very logical science, I believe. So the vaccines will still work just fine, is the next piece of good news. Does the new variant lead to more severe illness than the wild type? So illness severity, no statistical difference in hospitalizations, and no significant difference in 28-day mortality. So that's good. It's not making people more likely to be hospitalised. It's not killing more people. And again, let's look at the breakdown data of that, because that's the strength of this study. It's a cohort study comparing one group with another group. It really is like a natural experiment. All that data was just there ready to be looked at, because we're in this transition from people being infected with the old type virus to the new type virus becoming predominant, and this transition period is the time where we have two groups that we can compare the two groups against each other. Does the new variant lead to more hospitalizations than the wild type virus? So here we have data from 3,538 positive cases collected from September the 20th to the 15th of December. And in that group, from that 3,538 people, only 42 were admitted altogether for the new and the old type variant. But this is because this number will go up as time goes on, because a lot of people who caught the infection, say in December when it was spreading more, they hadn't had time to get sick yet. So this number will go up, unfortunately. It would be great if only 42 people were admitted to hospital per 3,500 infections, but it will rise. Anyway, the data we have so far: new variant group, 16 people were admitted, 0.9%. Wild, the old group, the wild comparison, the previous wild type virus, the old virus, if you like. 26 were admitted, 1.5%. And again, even in this provisional data, there is some slight indication that the new type mutation is not as making people as sick as the old type one. Having said that, I'm not allowed to say that scientifically, because you can only claim something scientifically if you're 95% sure. And these differences are not big enough, nothing like big enough, to give you that 95% confidence, that p equals 0.05 or less probability value. So really, returning back to speaking scientifically, I have to say that number there is exactly the same as that number there, because they are not significantly different. Now, when more data comes along, we might find that they are a difference between the two. But right now, we have to say that those numbers are the same. It's as if those numbers are both 20 or both 19. You know, that there is no statistical difference between those numbers. We can't claim significance. So not significant. Numbers are likely to rise in both groups with time. Unfortunately, as we know, the percentage of people hospitalised are higher than that. Probably still round about the 5% of people that are hospitalised from infections. We did look at, was it yesterday or the day before, that about 10% of people that are diagnosed are admitted to hospital about a fortnight later. Actually, 13 days is the peak time. But of course, we don't catch everyone with the antigen test, so it's still probably about 5%. This is why we've got such a big problem coming up over the next month or two. Anyway, let's stick with what we're doing now. Is the new variant more deadly than the wild type virus? So for this, we look at 28-day case fatality. So day 1 is the day of first symptoms. How many people are dead 28 days later is what this statistic looks at. Now, some people can, of course, get the virus and die after that time. They could die more than 4 weeks, 28 days after first symptoms. But that would be a minority of cases. Right, now only 2,700 cases reached the full 28-day time elapse since the specimen date. So only 2,700 people made the 28-day time because, of course, you know, this data only goes up to the 15th of December. But 2,700 cases, so these cases were obviously the people that caught it earlier. So these people caught it in late September, October, November time. That's how they could be included in this cohort, comparative cohort. So anyway, 2,700 cases had 28 days data or follow-up. Now, new variant cases, 12 out of 1,340 died. That's 0.89% died in the new variant group. The wild type comparator, of those diagnosed, 10 out of 1,360 who were diagnosed with the old-fashioned wild virus, 0.73%. And again, that number there, it looks like there's a few more dying with a new variant than that, but statistically those numbers are exactly the same. So the odds ratio there is 21% more people dying with the new virus, but of course, statistically speaking, that number there is exactly the same as that number there. There is no difference at all. And P equals 0.65 there is a huge non-significant result. Remember, to be significant, P must be equal to 0.05 or less. So that's massively more than that. So this result is not significant at all. That would only give you a 45% probability of there being a difference, and that's nowhere near statistically significant. So basically what I'm saying is, after all that going on, is that number there statistically is exactly the same as that number there. There's no difference between the two. Now, moving on to where there is a difference. Is the new variant more transmissible than the wild type virus? Well, yes, it is. Now, one of the ways they looked at this was secondary attack rates. So this is the 5th of October to the 6th of December. So this secondary attack rate is if the people that were diagnosed and reported to test and trace, how many of those passed it on to someone else? So of those that we knew had the virus, how many passed it on to someone else? That is the secondary attack rate. So the first attack rate would be the people that get it first, the kind of index case, the one we first become aware of. The secondary attack rate is who does that case pass it on to. So now, well over 1 million cases reported test and trace, so good sample size here. Of those, 46,273, 4.2% had genomic sequencing, so still a heck of a big number. Now, during this time, remember this only goes up to the 6th of December, and all the way from October to December, the percentage or the proportion of the new variant was constantly increasing and is still increasing. So 4.2%, 46,000 people had genomic data. 1,978 had the new variant, the variant of concern, the new type of the virus. 4.3% of those had full sequencing data. So this is done on good science. It's a combination of the antigen test and full sequencing data. Now they had a total of 228,361 of all the contacts notified by cases in this period became cases. Right, so a total of... So what we're saying is we had this number of index cases reported to test and trace. And a total, that number there of all contacts noted to test and trace in this period became cases. So in other words, that many primary infections there led to that many spread it to that number of people there. So that number of infections were identified, they spread it to that number of people there. So this is the secondary attack rate. Now 1.5 amongst those whose index case was confirmed to have the 15.1%. So of this number here, who got the infection, of this number here who got the infection, 15.1% got it from people with the new strain. 9.8% got it from those with the old strain. So there is the difference. There is the difference. So let me just clarify that. That number, over 1 million were reported to test and trace. That number caused 228,361 new infections. Of those 228,361 new infections, 15.1% of those who passed it on had the new variant, and 9.8% of those who passed it on had the old variant. So we can see that that's nearly 15 and that's nearly 10. So without working it out precisely, we can see it's about 50%. Of course, 50% increase in new infections. So 15.1% of those infected with the new virus caused new infections. Only 9.8% of those infected with the old virus caused new infections. That's the bad news in this video. Now, if you're a statistician, you can work it out exactly. It's going to be slightly over 50. I don't know. Anyway, it's about 50%. They're the differences. Can't work it out at the moment. Now, about 50% difference. Now, is this consistent with previous studies? Well, we only have one previous study. And the answer is yes, it is consistent. Now, we had thought initially it was probably about 70% more transmissible. But so we have that data there showing us about 50%. We had looked at this paper previously, this paper, Estimated Transmissibility. And that was from this mob here, Centre of Mathematical Modelling, Centre for Mathematical Modelling of Infectious Diseases, London School of Hygiene and Tropical Medicine. So a pretty sophisticated mob, to be fair. Anyway, their estimate was 56%. So we see that this new data from Public Health England, the difference between 15.1 and 9.8, is consistent with this data from about a week ago now. And they were 95% sure that the number was between 50 and 74%. So that looks like it's round about the number we are talking about. So the implications are obvious. This is already spreading throughout the UK. We need to minimise that spread as much as we can. We need to preserve the old form, which is slightly less transmissible. And we need to be doing that with all the measures that we have now. Cases are going up dramatically in the UK now. Now, I can't remember, today the 28th, it's about 55,000 new cases. I haven't got the figures at the moment. There's a massive increase. Hospitals are really stretched. We have to be really strict with ourselves just for another month or two. The Oxford vaccine will be starting to roll out on the 4th of January. That will change things. Hoping for the announcement tomorrow, certainly this week. But hospitalizations now, there's a delay in data between over Christmas, but the hospitalizations now, we know now, are actually slightly higher than they were in the peak and the 12th. And they're going to carry on increasing because of the pressure from the cases that have increased throughout December. So tier restrictions will be increased in many parts of England tomorrow and are already high in Northern Ireland, Wales and Scotland. It's not a good time in the UK. But anyway, we've got that data there. So not increasing risk of reinfection with a new variant. Vaccine should be fine. Not causing more severe illness, not sending more people to the hospital, not causing more deaths, but there is increased transmission, about 50% is where we're at. Let's just hope it doesn't carry on spreading to other parts of the world. And I'm also concerned about the South Africa variant as well, because that seems to have the same kind of accelerated or increased transmissibility, and we have limited data on that. But let's hope that is not spreading out of South Africa. Okay, that's us for today. Let's hope we have the good news on the vaccine tomorrow. But thanks for watching tonight.